Now we move outside to a street, actually a street in Malaga, in Spain. Here, the survey was made with our SLAM scanner X120 Go. It was a single scan, about 200 linear meters of walk in about 10 minutes. And the goal of this survey was to map the area for construction and maintenance purpose on this road. So the words to you is up to you. You can show to us what you can do and we can do with Aplitop software on this dataset.
Okay, thank you, Chiara. So let me show the video. Here are the videos, and I'm going to show the urban outdoor study case. So we can see here that we have a point cloud in a raw mode. So the first step, as we have seen before, is to do a cleaning up of the point cloud. The idea is to get only the points of our area of interest. So the first thing we have done is selection by polyline and hiding the points. Now, if we inspect the point cloud, also we have a big problem that are noisy points under the ground. To avoid this issue, we can do a selection by elevation. With this tool, we can select an upper and a lower limit, and all the points in between will be selected. So the application shows in orange color the points that are going to be selected before you apply or accept. Once they have been accepted, you can hide them, so all the points below the ground have been selected and removed. Next, we do a lighter version of the point cloud using the density filter like we have shown before. And this way we can see that parts of the point cloud are more dense than others. So the idea is to have an homogeneous point cloud with points separated or a distance that is more or less homogeneous. Next thing we do is do an isolation selection and filtering, because we have scattered points that don't provide meaning for our purpose. They don't define well surfaces or things like that. So the best thing is to remove also these points. So we hide those points, and once we have more or less a clean point cloud, we make a clone, a copy of this point cloud that will only have the points that we are watching now. So the other objective in this work is to have a classification. Now we are going to show the capabilities of classification over the raw point cloud. We see first that we have 2 point clouds, one that is cleaner and the other that was the raw, and one have a lot more points than the other. Anyway, with the artificial intelligence classification tool that will be included in the next release of our application, we are able to classify 2 models of a scene, outdoor and indoor. In this case, it's the outdoor, where we have several classes like ground, buildings, trees, and things like that. And also the model includes vehicles and street lining. So once we have classified with the tool, we can see the results here. In the distance, it seems good or good enough, but if we take a closer look, we can see that we have some mistakes or points that haven't been classified. So to avoid this thing, we have also developed advanced selection tools like the vicinity selection that is showing now, that allows us, for example, select an object that is vertical, setting that the point that we are going to click is the lower point, and it will select all the points that are connected with that point. This way, we can select this tree that was badly classified and choose as a classification like a high vegetation and assign this classification to the selected points. This way we can edit the classification manually, and cases that are harder, like this one, where we have two objects very close one to the other, we can use the clustering selection that also is a beta feature of the application, and also will be included in the next release of the application only for a time, and in the future maybe it will form part of a professional version or something like that. And with this tool, we can select the light street that is closer to the tree, and only the light street is selected. As we have done before, we can choose the class or classification we want to assign, and this way we assign this classification. This is the final result of the point cloud classification manually and automatically. So at the end, we can hide or show different classes, and this way we can inspect the area and view what elements are. For example, we have for manual classification, we have added a few more classes that we will try to add in the future to our intelligence model to detect or to classify. And that's all in this study case.